Hey, Brother Jones. This is Tyler Harmon for my individual final project presentation. I have to apologize right up front. My HOA is doing a Pioneer Day celebration thing down at the park, so had fireworks going off nonstop for about the last half hour, so we may hear that in the background. First of all, I'd like to explain the difference between static versus non-static or instance variables. So with our class instance variables, um, these are not static, meaning they can be changed, they can be modified. But in order to reference them, we have to create a new instance of the class. So for example, we see here our public int wheel durability. It doesn't say static, it's just an integer, and the variable is wheel durability, and it's been set to a value of 100. Whatever changes we make to that, whenever we reference it and call it and create a new instance of the class, will only be changed within that instance. So for example, if we see here calc wagon wheel degradation, we've had to create a new instance of the class. So wagon equals new wagon. So it's a new instance of the wagon class. So we reference it down here. We call it wagon.wheel durability. I don't have the entire function here, but as we go through, this is basically trying to test what the wagon wheel durability is. It starts at 100. As we go throughout the game, it will decrement based on different variables. Those variables, when they change, they'll be stored within this instance of the class. So when we reference it again, when we run the function again to try to calculate the new wagon wheel durability, it'll pull up the old reference and the data from that instance. But I could not go into another class and try to call wagon wheel durability and have it have the exact same values. So in a static class variable, these ones from the very beginning of the game are retained in memory. They're fixed, they're never going to change. And what's nice about that is it can be referenced from any other class in the game at any period, and it's going to be the exact same variable. So for example, in my game class, we have the variable current game, and we have the function game get current game returns the current game. So down here, if I want to get the current scene, all I have to do is reference Pioneer Trails.get current game, and it's going to return this current game value. And then, of course, I'm going to get the map and get the scene and everything else. All right, so arrays versus array lists versus enums. Right off the bat, we only used arrays in our program. So far, there's some things that we didn't get to implementation of, but we'll go ahead here. So arrays, they're containers, and this container is a fixed length. So you can see right here, my resource array, I have to create this new instance of it, and we've set it to 25. So in the beginning of this thing, you have to set the length, and it's not going to change. And anything that we put in here in position 1 or 2 or 3 or whatever, it's pretty much going to be the same thing. The thing that's nice about arrays is you can store primitive values. So we can have strings, so like here we have string and integer, we can have booleans and anything else. We can also store objects. So this is good for a fixed list. So like here, I didn't show the whole 25, but we created some resources that we would find down here in each scene. And so like in scene 0, for example, it's going to have resources 0, which means that they could find a hammer, a quantity of 1, and a weight of 10. The other cool thing about arrays is that they're multi-dimensional, which means that you can have arrays of arrays or multiple arrays within the thing. So I've showed that here in where we're assigning scenes to locations. You can see over here with location, there's 2 sets of the square brackets, which means that it's 2 different arrays. So when I call this variable locations down here to set the scene to scene 0, I also call row 0 and column 0 and set that to 0. And then the next time I call the array row 0 and column 1 and set it to scene 1. So that's a nice thing about arrays. For array lists, these are variable length. You don't have to set the length in the very beginning. You can add to it, you can sort it, you can subtract from it. But the thing with this is it can only store objects. So you'll notice here that capital integer and capital Boolean, because those are objects, an integer object and a Boolean object. As I mentioned, so I have this. This was from our code. We didn't actually get to implementing it, unfortunately. But the thing that's nice about array lists is it's good for dynamic lists. And so we're going to use this for the resources that we would put into the wagon so that we could take things out, we could put them back in, as we found food on the trail and different things like that. But the other thing with array lists is they are single dimensional. You can only have the one array list. You can't have multiple array lists. Enums we also did not use, but this is for a group of named constants. So for the example here, I got this from Stack Overflow. They made an enum for a car, and in it they specify Lamborghini, BMW, Audi, Fiat, and Honda. This is pretty much fixed. This is what the enum is going to be. It's not going to be sorted or modified. And this is something that's really good, like this list of cars that's not going to change. You can use it for days of the week, for months of the year, for holidays, things like that. So also, and you know what? I just realized that I didn't put this into my presentation. So I'm going to go to my code real quick so that I can show you iterating through an array list to access each element that's stored in there. So if I pull up NetBeans and I go in here, trying to remember where I had it. Okay. So in my view symbol report, basically what this is doing is we're pulling this location array. So it's a regular array, it's multidimensional, and that's for where I get my locations for my map. So as I start, each row starts at 0. As long as the row is less than the total rows, I'm going to increment that by 1 each time. Same thing for columns, start at 0. As long as it's less than my total columns, we'll increment that. And so what this report does is as I pull in the scene and get the locations, I get the row and the column and the scene, the console is going to print out in this format the scene.getName and the scene.getSymbol. And so what we end up with is my report that pulls this up. And so it's referenced through that array, it's iterated through it, pulled the first location, the first symbol, the second location, the second symbol, all the way down to the end. And so that's how we can go through an array and array list and pull out the different location. I ended up just printing out everything, but I could say a specific index and say I want the name and symbol for whichever index that happens to be in that location. So as far as error reporting, we can create custom runtime errors. So we initially did this where we just had an error would come back or it would return a value of -1 or -999. But we were able to change that so that there were specific messages based on whatever we happened to run into. So basically what happens is you set up some game control exceptions with a number of attributes. And so in here, this is in my game control as it's trying to save the player's name. So it's going to try to do that. If it can't save the player, it's going to catch this exception and it's going to throw this message. So it's going to display the error view. that says, sorry, there's a problem with the game. Same thing with the player. If the player comes up null and it can't save the player, then it's going to throw this new error that says, sorry, there's a problem with the player, so that you know what you need to look at and fix that. Here's another example down here as we create the new game. If it cannot get the player, if Pioneer Trails that get player equals null, then it's going to throw this new game control exception with this custom message. Your name has to have at least one character. I don't have it in this code, but right up here where it has game control exceptions EX, instead of putting this very specific message right here, I could also call ex.getMessage, and it would get the standard message for what we've specified in game control exceptions, or if map control exceptions, it would call that specific error as well. So as far as character versus byte stream, character is for more sophisticated data. It's where we have the reader and writer. We use buffered reader, buffered writer. This is for Unicode text, so it can use everything. It can read all the characters, and it reads the files character by character. So we're going to use this for text files or anything pretty sophisticated. Byte stream, on the other hand, it only reads files byte by byte, and it should only be used when you're doing primitive input and output operations. For example, it can't read a text stream. So if we use input stream and output stream for just some really basic I/O where it's reading binary things, then you can use byte stream. Otherwise, you should use character stream. All right, so now I'm going to get to demonstrating some of the code from the game and how to write to a file. And let's see, here's my NetBeans. So I'm going to pull up my program. Our game is Pioneer Trails, but Bonnie changed it to Snarky Trails because she was feeling snarky. But anyways, we start the game, it throws this up, it explains what the game is, we input our name, we've input Tyler, returns thank you, or welcome to the game, Tyler, we hope you have lots of fun. So I can start a new game by hitting N, and you'll notice here that it welcomes us to Nauvoo, the city of Joseph. So it's pulling in the information, our first city, or our first place name, and the first description. I can hit M to open the map, and that shows us that we are currently in Nauvoo. We can do all kinds of things. We can go to the help menu and see what the goal of the game is, get help on how to move and all that different stuff. Go back to that menu. In our location menu, this is where we're going to show you how to print the report. So if I go to view location symbols, it asks if I want to view or save the location report. I want to save it, and I'm going to say it's report.txt. Hit enter, it says that that's been saved. I'll hit quit. Then I can go back here to report.txt. It was just updated for 10:24 p.m., which it is right now. If I open that, it shows that same report that I showed earlier, but it's just a new instance of the report. So let's see. We can also continue our journey, and this is how we can win or lose the game. There's a lot of stuff that we just didn't get to, unfortunately, but we learned a ton. So if I hit C to continue journey, basically what happened is it says press Q lots of times to end your misery, because welcome to Sugar Creek, the little Switzerland of Ohio. Press Q to keep on keeping on. Oh, that did not work how it was supposed to. So we are going to go back, hit C. Here it is. So it's time to end our misery because our food was stolen by bandits, and so the game is over. And so there's not a ton of strategy to it. We just needed a way to win or lose. So basically, this is going. I'll show you real quick. It's just going and it's randomly finding these messages. So most of it is keep on keeping on. We're doing great, and then you can continue on to the next places. Otherwise, you're trampled by a buffalo or any of these other things that end the game. I am approaching 15 minutes, and unfortunately, this stream is going to cut out at 15 minutes. But I just wanted to say thank you for everything. I've thoroughly enjoyed my time in this class and really appreciate everything you do.